Hello, explorer. Welcome along. Let's take a little break from life here on planet Earth, shall we? And see what else is out there. It can't just be us. There must be something amazing lurking through the universe. We'll find them in a brand new Fun Kids Science Weekly. My name is Dan, and this week, with loads of echoes, you can hear why sound bounces back to you.
An echo is just a reflection of sound, a bit like if you bounce a ball on a hard floor, the ball bounces back. An echo is just the same thing, but with the sound.
Also, for millions of years, sharks have ruled the seas, and we'll learn how they've stayed the ultimate predators.
Sharks have been around longer than trees and longer than grass. They are some of the oldest vertebrates in our oceans. But importantly, they're also some of the most threatened vertebrates on Earth today.
Plus, for our Dangerous Dan, we'll hear all about a lizard that looks harmless but sweats poison. It's on the way in a brand new Fun Kids Science Weekly. Let's start off with your science in the news. And it turns out stress makes your nose get colder. Scientists from the University of Sussex have used thermal imaging cameras. You see them loads in spy movies. They show how warm things are by making them glow redder, and the yellow stuff is colder. Well, it's shown that when you're stressed, your nose gets brighter, it gets lighter, and that means it's colder than the red bits. You see, stress changes the way that blood flows to your face. Maybe it concentrates it to your brain because you need a lot to think through. And scientists have showed that when you're stressed, blood doesn't rush to your nose, which is why it gets colder and why it looks so yellow. Isn't it amazing that we're still discovering things about your face and what your blood does? And it's thought that knowing different temperatures and colours of our face, it tells us how stressed we are, and that can help us understand and work through different situations. Also, here's some brilliant news. The green turtle has been rescued from the brink of extinction in what scientists say is a major conservation victory. Green turtles found under the ocean, they're named after their, green body fat. It gets its colour from their plant-based diet. And it used to be hunted from the ocean for turtle soup, for eggs to eat, and for its shells, which people would use to decorate their homes. Its numbers plummeted, and it's been listed as endangered since the 1980s, but now, thanks to conservation efforts, from protecting eggs and releasing babies on beaches to stopping the amount of times they're accidentally caught in nets, the numbers are really rebounding. This is brilliant, isn't it? We hear so much in science about what we're doing to maybe save the planet, or to search through the solar system to find new things out there. But I really love hearing about fantastic efforts to help the creatures that we've already got here on planet Earth, and that's a brilliant one. Our final story this week, a group of scientists are leading the charge to make computers out of living human cells. We're entering the weird world of biocomputing. Let's find out more with Dr. Fred Jordan, co-founder of Final Spark, who are at the front of this field. Fred, thank you for being there. Biocomputing, can you just tell us more about why it's needed?
Why it's needed. So the first thing, it's about science, So when you do science, you try to do things which have never been done before, just to explore new technologies, new way to understand how things work. So here there is one application which is obvious, okay? It's that human brain consumes like 20 watts. Biological neurons are like 1 million times more efficient than the artificial neurons which are used in artificial intelligence. So if we could do a biocomputer, it would be vastly more power efficient than any silicon-based computer.
So just to make this clear, you're trying to make a computer out of the cells that make our brain, is that right?
Yes, correct. Yes, we are trying to use the neurons actually to connect them together, and the structure that it creates then is called an organoid. So it's like a small organ which has thousands of neurons connected together, and we interact with this, I would say, bunch of neurons using electrodes.
So where are you getting the cells from to begin making these brain computers?
Well, today you have suppliers that give to researchers so-called stem cells, human stem cells. And from these stem cells, you can actually create any kind of cells of the human body. And in our case, we create neurons.
What would a finished kind of computer look like made of these cells, do we think?
So, well, at this point, if you come to the lab, you will see many tubes, many cables everywhere. And the nervous tissue is really not easy to see directly from the outside world. But ultimately, we want to build a server that will serve millions of people. So then you would have a nervous tissue which is absolutely visible, because it would take like 30 centimeters of thickness with 100 meter long by 100 meter. So it would be quite a giant, actually.
So this sounds like it could do a lot of good because it's such brilliantly quick and powerful processing speeds. How could this help the world around us in the future? What difference might this type of computing make?
You know, if you look at the projections of AI and servers used to perform AI, the power consumption is going to rise in an incredible fashion in the coming years. And it's already consuming a lot of power, but it's going to be way, way more. All right. If we can replace silicon-based computer by biocomputer, basically we will divide this consumption by several orders of magnitudes, actually to the point there will be no environmental problem anymore of doing such computation of AI.
Well, looking into the future, you're leading the charge. You're far down the line with this process. Is it something that other companies might be able to do, or is it so expensive and it's so hard to get hold of the stem cells and put it together that really this is a nice idea but might not be possible to be repeated?
So you're right, it's not easy, but it's not that expensive, all right? It's complicated, but not that complicated. And we are not the only company, but you're right, there are only a few ones in the whole world doing this. And actually, we hope that it's going to be a new industry so that there will be more and more companies working in this field. Because at this point, we need more momentum of people trying to do this.
Now, when someone hears this, well, many people might say, oh, this all sounds a bit strange. Making servers, making giant computers out of human cells, making like a living brain that's powering AI. They might say that sounds a bit strange and a bit like a company is playing God or meddling. What would you say to something like that, Fred?
What do you think 2,000 years ago when people were dreaming about flying in the air? Okay, like a human being, it was considered that only gods could do this. All right, so it was not an acceptable thinking. It was surprising and even shocking that a human being could fly. And 2,000 years later, today, we all can fly in a plane, and we know we are not competing with gods by doing this. All right, so I think everything which is new, really, really fundamentally new, is going to lead us to have this kind of reaction. And I have the same kind of reaction, by the way, I'm not different. So, but we have to get used to new ideas.
Well, Fred, one last question, and thank you so much for joining us. We're far down the line. When might we see a final version of this?
So I hope that we are able to release the first biocomputing server in 12 years.
Amazing. Well, listen, Fred, Dr. Fred Jordan, thank you so much for joining us.
It was a pleasure.
Well, thank you to Fred for coming on, explaining all about how we're making computers out of mini human brains. I love the chat, but it sounds amazingly strange, doesn't it? Computers out of brains? Thank you, Fred, for coming on. Let's get some questions on, shall we? If you ever have anything sciencey that you want answered on the podcast, make sure you leave it as a voice note for me on the free Fun Kids app. You can do it at funkidslive.com too. That way you can star in the show and we'll hear what you're about. And we'll find a genius to sort it out for you. All right, let's get on. A review sent in through Apple Podcasts. Kubi has sent this in. Thank you, Kubi. How do chameleons change colour? Well, it's amazing. They've got very special cells in their skins. Chromatophores, iridophores, and melanophores. Now, here's what's cool, right? It doesn't change colour by mixing pigments, by mixing colours and shades like you would if you were painting. It changes how light reflects from its skin. So it's almost a trick. It's like an optical illusion the way it works. It's fascinating. You see, the top layer of the chameleon skin, they are the chromatophores. They contain some colours, some pigments, yellows, reds, browns. In the middle, the iridophores, they've got microscopic crystals in them that reflect, that scatter light. Imagine shining a laser at a crystal and it bends. It goes in all different directions, doesn't it? The bottom layer of skin cells, it's got the melanophores. They have dark melanin pigments. Now, when a chameleon is relaxed, the crystals, they are close together. This means they reflect the short light waves, the blues, and that mixes with the yellow pigments on the top of the skin to look green. A bit like you're mixing paint, but not quite like that, right? Blue and yellow makes green. When it's stressed, those crystals in the middle of the skin, sandwiched there, they kind of stretch apart and they reflect the longer wavelengths of light, which are normally darker. And they let the dark pigments underneath be seen more, which make it a more sinister, menacing colour. It's an amazing combination of physics with the light reflection and biology with the cell control. Now, changes in temperature or mood or the environment, they make the chameleon's brain send signals to change the crystals so they can be a different colour. This might be to blend in, to change their temperature, or to attract a mate. It's amazing that all that's going on through such a strange colour-changing creature as the chameleon. Kubi, thank you very much for the question. Let's get in a voice note. This is from Gabriel. What do you have? Or should I say, and this will make sense, what do I have?
Hi Dan, my name is Gabriel, and I want to know what are echoes and how do they work?
Gabriel, thank you for your question. What are echoes and how do they work? Is there more science to this? Shall we find out? Associate Professor David Chappell joins us from Nottingham Trent University. David, thank you for being there. What's an echo?
An echo is just a reflection of sound, a bit like if you bounce a ball on a hard floor, the ball bounces back. An echo is just the same thing, but with the sound.
So how does it work? Because I'm pushing out, when I speak, I push out vibrations that move the gas. What's happening? How can they bounce back to me?
Okay, sure. So the sound that you hear when you talk is a wave that causes the particles of air to move around. And that movement causes the wave to travel through the air until it encounters an obstacle. And if the obstacle it encounters is a hard surface, then it will reflect back off that surface. Whereas if it encounters something soft, like a soft furnishings, carpet, just something porous and soft, then that will absorb the sound instead and you won't get an echo.
There are some strange things with echoes, aren't they? Where it's something like you can go to the world's quietest room and they kind of mess with your brain a bit when you can hear echoes and they send you a bit round the twist. What's happening there?
Okay, so like quiet rooms, that's probably the absence of echoes. You can create rooms where you get no reflections of sound using carefully designed sort of pieces of essentially like sponge. That means that absolutely every bit of sound's absorbed, and when you talk, your voice goes dead really quickly. You don't hear any kind of it sounds a bit spooky, to be honest with you. The opposite you can get is like a reverberation chamber, which is where they make all the walls really, really reflective. And then you hear lots and lots and lots of echoes, which is, also a little bit strange to be in. But these are the sorts of things that scientists who do acoustics use these sorts of chambers to do measurements and learn more about sound.
Is anything lost, David, when my voice perhaps echoes back to me? Is there a volume change? Is it getting quieter? How long can this go on for?
Yeah, absolutely. Yeah, so it does get quieter because some of the energy from the wave is absorbed into the reflecting surface, and some of it's reflected. And like I said before, the amount that's reflected and the amount that's absorbed depends on the material it hits. You get absorption. You even get a little bit of absorption as the sound travels through the air. That's why, if I talk where I am in Nottingham, you don't hear me miles and miles away, because the sound gets quieter and quieter the further you are from me as it's absorbed, as it moves through the air. But sound's absorbed more quickly when it encounters, as I say, like a porous material such as, a cushion, a curtain, anything soft.
Well, Gabriel, that's what echoes are. It's your voice or a sound bouncing back to you, and that's how they work. David Chappell, thank you for joining us.
All right, thank you very much.
Thank you very much to David for coming on the show, helping us understand all about echoes. If you have a question that you'd love answered on the show, make sure you leave it as a voice note for me on the free Fun Kids app. You can do it at funkidslive.com too. Now, if you are really quick listening to the show and you're around the north of England, or you fancy a drive, well, you've got 2 chances to see Fun Kids Science Weekly live this year. If you're not listening to it on a Saturday, you've got just one more chance to see Fun Kids Science Weekly live this year. On the 18th of October, the day this is released, I'm doing Fun Kids Science Weekly live at the Carriage Works Theatre in Leeds. You might have missed that, so you've got one more chance in Chelmsford. That's on Tuesday, the 21st of October. When you finish school, I will be there. Your last chance of the year to explore the universe with me. We'll have dangerous, slimy, strange, stinging creatures, genius guests, explosive experiments. We'll have a rocket race and your chance to hold something from outer space. I have taken a meteorite all around the UK. It's got one more stop for 2025, and that's at the Chelmsford Theatre on Tuesday, the 21st of October. I'd love to see you there. We'll do selfies, we'll do high fives, and there's still some tickets left if you want to grab them. Get a grown up, head to funkidslive.com/tour to book your place. It's time for this week's Dangerous Dan then, where we learn about the weirdest, most unique and strange things in the universe. This week, we are headed to find a lizard which looks harmless, but is secretly dangerous, and it's got a brilliant name. You'll find the blue-tailed skink around the world in North America, Africa, Asia, and the islands through the Pacific. It was once only found on Christmas Island. Christmas Island is called Christmas Island because it was discovered by a sea captain called William Miners on Christmas Day in 1643, which is fascinating, but takes us away from the lizard. This creature grows to around 20 centimetres long. They've got a thin, shiny black body, normally with yellow stripes across it, and a brilliant electric blue tail. Now, that blue tail is meant to distract predators because, well, it's bright. So a creature coming along thinks, what's that? I might take a look. I might take a little nibble of that. And it's also detachable. So a predator grabs it, it comes off, it wriggles wildly, while the lizard, free of the tail, gets a chance to escape. And that's not the only way it defends itself. It can sweat poison. If someone gets too close, it pumps out a dangerous toxic juice that can irritate a predator. And if it gets eaten, that sweat gets swallowed, and that makes things even worse. They can carry salmonella, which is something you might have heard about, that causes food poisoning. Well, this creature can cause liver poisoning. We don't actually know too much about its toxicity, how it works, but we do know that it causes vomiting, it makes the victim exhausted, it feels heavy, it can even be fatal. And that is why this brilliant blue-tailed skink goes straight onto our Dangerous Dan list. It's time for Battle of the Sciences, where we try to discover once and for all what is the greatest science in the history of the universe. And today, we're going under the ocean for something that you might be terrified of. And we'll find out, hopefully, why you shouldn't be. We're talking paleobiology with Dr. Jack Cooper, who joins us. Jack, you have 1 minute to tell us why paleobiology is the greatest of them all. That minute starts in 3, 2, 1, go!
So paleobiology is essentially the study of the history of life on Earth, and that includes prehistoric times. So not just your sharks that still with us today and lived over 400 million years ago, but also things like dinosaurs. And the importance of paleobiology is essentially understanding how these animals that lived in ancient times lived alongside each other and survived environmental changing events. And this can actually help us look into ecological effects of what might happen in today if we lose species, and therefore help inform conservation. So you can learn a lot about the past, and you can maybe help out with the future.
Jack, I love that. Now listen, that was well under your minute, so thank you so much. I know that you're really interested in sharks, so why does studying creatures from the past help you better understand sharks today?
Well, in this case, it's specifically because sharks have been around longer than trees and longer than grass. They are some of the oldest vertebrates in our oceans. But importantly, they're also some of the most threatened vertebrates on Earth today. So essentially, if we can understand how they were contributing to ecosystems, be it as apex predators eating smaller fish, or as nutrient transporters, essentially helping ecosystems thrive, if we can see how that was working in the past through the fossil record, we get a better appreciation of how they are doing this today and what might be lost if their populations decline.
So many people are terrified of sharks. You are fascinated by them. What is it that amazes you about these creatures?
To me, it is that enormous longevity, the fact they have been around for so long. They have incredible diversity as well. You get sharks in the fossil record that look a bit like pancakes or rays. You get absolutely gigantic sharks like the megalodon. But today in the present, you get filter feeder sharks like the whale sharks, the iconic great white shark. But you also get tiny little sharks like the epilude shark that can essentially live on the seabed or even walk on land when the tide comes out. And to me, it's the fact that they have that enormous diversity and have been around for so long that ultimately makes them so fascinating. And essentially, the story of sharks is the story of the history of life on Earth.
So why have they been able to be around in slightly different forms for so long without too much threat? Why are they almost indestructible?
I think it comes down to a number of factors, one of which is that typically it is that diversity and the fact that you have smaller sharks as well as your famous big sharks that tend to go extinct when we see big extinction events like the one that famously wiped out the dinosaurs 66 million years ago. But a lot of those smaller, lesser-known sharks have essentially pushed through because they can feed themselves and feed on a diverse range of foods. And I think it's that diversity of body forms, but also that diversity of diet and ecological role that has helped sharks live for as long as they have done.
Now, I love chatting to scientists about what they do every day. Now, you're fascinated by sharks. We have some around our shores here in the British Isles, where you and I are. But also you're looking at things from millions and millions of years ago. So how on earth are you studying these creatures every day in a lab? What's going on?
So in terms of today's sharks, you can examine them in lots of different ways. You can go out in boats and even snorkel with them and see how they're doing. Or it can be as simple as taking a drone out and filming them and seeing what you find there. For example, in Wales, we've just seen evidence of a porbeagle shark, which is essentially looks like a baby great white shark. But when it comes to their fossil record, we're limited often to their teeth, which typically are falling out of the shark's mouths constantly. They are always being replaced, and they are very, very good at preserving the fossil record. They go through thousands and thousands of teeth, and by studying those teeth, you get an idea of how big a shark was and what and how a shark was eating, which can tell us quite a lot about their ecology. So I guess to summarize, there's lots and lots of different ways in the present to look at sharks, but in the past, it's essentially detective work using those teeth.
I said that quite a few people are scared of sharks. Now, they fall into the same bracket as spiders and snakes, and they just look a bit weird and mean, some might say. Jack, very simply, should we be frightened of sharks?
Absolutely not. Sharks generally are very, very rare threats to people. I think we have an utterly minuscule number of bites per year. But that being said, sharks are also wild animals, and you get large apex predatory sharks. So in the raw circumstance, yes, that can be dangerous. So I think We should not be scared of them and see them as monsters. We should, however, also respect them for what they are, which is apex predators.
Now, I always finish these chats in the same way, Jack. Let me throw you forward years and years and years and years towards the end of your career in paleobiology. What's the one thing that you really want to know about your science? What do you want answered about sharks?
I would love to know just how far back sharks stretch. So it's often thought that modern sharks first evolved about 250 million years ago. And but actually their ancestors go even further back to about 400 million years ago, and perhaps even further to 450 million years ago. I'd love to find that link to the very, very oldest shark.
Well, we're talking sharks and paleobiology. Very sharp teeth, loads of them. Does it make it to the top of our Battle of the Sciences leaderboard? It's a good fight. Thank you, Dr. Jack Cooper.
Oh, thank you very much.
So in Battle of the Sciences, just a second ago, we chatted to Jack all about an amazing shark. And we can dive deep into the ocean again now with our undercover engineers, finding out all about shark detection technology and the artificial reefs that are saving our oceans.
Hello, this is a podcast by the IET. We team up with inspirational engineers from around the globe who are all working to make the world a better place. Could you be one of them? From missions to Mars to technology exploring the deepest oceans, from nanotechnology to the design of some of the largest structures on Earth, exciting new innovations in engineering are changing and shaping our world in some amazing ways. And here's the thing, whatever your background, whatever your interests, engineering can help you be a part of this change. In this series, we're going undercover to talk to some engineers right at the forefront of some exciting new areas of technology. Ready? Let's take a closer look.
Hello, I'm Becky. Welcome to the podcast. In this episode, we're going to be diving into the world of ocean engineering and talking to expert Ludovic Grosjean to find out more and to hear how by working together, engineers are solving some of the planet's biggest problems. Now, you might be wondering how engineering has anything to do with our oceans. After all, we usually think of engineering as being something on dry land. So, Lloydie's here to tell us more.
Ocean engineering is a field of study that deals with the design and operations of man-made systems in the ocean and other marine bodies. Or put another way, ocean engineers have the technical expertise and skills to find solutions to problems related to oceans. This could be creating physical or mechanical things, such as autonomous submarines for super deep ocean study, or drones for monitoring, or creating computer programming, sometimes using AI and machine learning to identify patterns and sort data, perhaps relating to weather patterns, levels of pollution, or the movement of marine life. Ocean engineers might be inventing instruments to record levels of chemicals or pollution in waters, or using sonar to locate marine life.
Thanks, Lloydie. So how are engineers making the difference? Let's talk to an engineer who's right in the swim, Ludovic Grosjean.
Ocean engineering is a field of study that studies the design and the operation of man-made systems in the ocean and other marine bodies. But more specific, I don't just do ocean engineering. I do environmental monitoring, which is a little bit more specific. You see, with ocean engineering, there are a lot of jobs that you can have associated to it. But with environmental monitoring, I monitor not only the ocean, but I also monitor the environment in general, which means there are a lot of applications in terms of working with the Bureau of Meteorology and all the applications involved in that, as well as working with all technology for monitoring the water quality. So there are actually quite a bunch of technology I'm touching to, and that's why it's so great to be an engineer.
So, let's dive down further to find out more about all the different things that ocean engineers might be working on.
Thanks, Becky. So some ocean engineers work to find solutions to environmental problems. This might involve using drones to monitor pollution, which might be plastic waste or toxic substances, such as after an oil spill. There's also work to be done monitoring cleanup operations. Other environmental projects might involve creating artificial reefs to preserve marine life. Another area of ocean engineering is all about exploring the deep. learning about the physical properties of the ocean itself and the marine life that makes the ocean its home, including those found at the very deepest levels, creatures that can have very unusual characteristics because of the conditions and extreme water pressure. And you can't observe things like that from the surface, so a lot of ocean engineers will be working on vehicles that can travel to those extreme depths, whether submarine vehicles with people on board or unmanned autonomous observation technology. And ocean engineering can help keep us safe. There are projects to monitor the weather and environmental conditions which might impact us on land, making predictions about things like high winds or flooding. Scientists think that climate change may result in more extreme weather conditions, so the more data we can collect, the more analysis we can carry out, and the better prepared we'll be.
Wow, it's a really diverse field.
It's not a field, Becky, it's oceans.
Very good, Lloydie, thanks. Let's hear more from Ludovic and find out a bit more about him and how he came to work in this field. I mean, ocean, well, you know what I mean.
I've been working as an engineer for quite a number of years, and the one thing that I noticed is technology cannot be used for everything. You might think technology would solve all the problems, and the reality is I discovered as an engineer that not. The main thing is you have to work with people, and when you have people working with technology, that's where things can change. And that's why my famous quote of saying that if you can detect pollution, you can remove it, is because we need not only the power of technology, but we also need the power of people. We need social media. We need to move people towards the goal of making a future for the future generations. If you have creativity, you can really imagine the future of technology, the future of the world. With creativity, you can think outside the box. You can solve the biggest world problems. My grandfather was an engineer, and he was actually working in the environment as well. He spared his last moments to tell me, what can you do in this world to make this world a better place? And I thought about it, and I was like, this is it. Engineering is going to help me to achieve that. And by following the steps of my grandfather, I would be able to achieve his dream, which was to make the world a better place.
So let's check out a real-life case study to see how all the tech is being put to work. And it's all to do with a rather fishy problem.
Fishy problem, I get it. Yes, it's about sharks. Now, that might not be much of a problem for swimmers in this country, but in other parts of the world, it's a hazard that authorities have to take very, very seriously. With this in mind, in Australia, the New South Wales government are going to be using a fleet of drones to continuously monitor the coastline and act as an early shark detection system that will allow beachgoers to be removed from the water earlier than before. The drones will be deployed at 34 beaches that sharks are known to frequent and will be flown by surf life-saving NSW drone pilots. The drones automatically detect the size and species of a shark and pinpoint swimmers in distress. Drones are already being used by Australian lifeguards to monitor and track sharks swimming in and around popular beaches. The drone known as the Little Ripper uses AI to detect sharks, alerting lifeguards and emergency services and swimmers. The shark spotting drone has a 90% accuracy rate, while current manned aircraft have accuracy rates of around 20%.
Very snappy. Thanks, Lloydie. For now, we're out of time. But if you want to find out more about where engineering can take you and how you can be a part of the change in the world, you can get undercover info by going online to theiet.org/undercover engineers. Join us again soon.
And that's it for the Fun Kids Science Weekly. You've got one more chance to see this show live in 2025 if you're in the UK. And you've got some time. Come along to Chelmsford on Tuesday to explore the universe with me. funkidslive.com/tour if you want to get a ticket. Make sure you've got a grown-up there with you. You can hear loads more of our brilliant podcasts. We had Undercover Engineers on today. We've got tons more. Wherever you're listening, Google, Apple, Spotify, they're on the free Fun Kids app and at funkidslive.com too. Fun Kids, we are a children's radio station from the UK. You can listen all around the country on our app, on our website, and if you've got a smart speaker, wake it up and ask it to play Fun Kids.